Okay. Hello, students. Good morning to all of you. Hope you had a good extended weekend. So today we will get into in the last class we had discussed about or revised about factors affecting plant locations and all. In this class we will get into the techniques of plant location like factor rating method, weighted factor rating method or qualitative factor rating method, load distance method, centroid method, minimax method. All these methods are there. So we will discuss them one by one very briefly, and each one of them is important. So please carefully observe this, and I hope the PPT that was shared with you earlier is there with you because it's a revision class. The PPT has already been given to you. On that PPT only, I am going to revisit the session once more. Okay? All right. So the first technique is factor rating method. In factor rating method, list the most relevant factors in the location decisions. What are the factors we have seen in the earlier slides? And out of those factors, which factor seems to be most important for me? I will list out those factors first. Then what I will do is I will rate each factor according to its relative importance, say from 1 to 5 on a Likert scale. On a Likert scale, I will rate each factor from 1 to 5. 1 being the lowest importance, 5 being the of the highest importance. So there can be as many factors as I want. Okay. Rate each factor for each location on a scale of 10. Now, for every location, every factor may not be important. For each location, factors' importance might change. So we have to rate the factors' importance individually and factor per location individually. Try to understand the difference. We have to rate the factors' importance individually and factor per location individually. So two types of rating is there. One on a Likert scale, one on a scale of 1 to 10 or 1 to 20, whatever. Compute the product of the ratings by multiplying the factor rating with a location rating. So location ratings are available for location A, B, C, D. We have got plenty of locations. For each location, we have the location rating and the factor ratings are there. We multiply the factor rating for each location. In the next slide only, we have seen the factors are tax advantage, labor skill, proximity to customers, 3, 3, 5, 1, 5, and all. And there are two locations, location A and location B here. And the product of the rating is location A into factor rating gives you product of rating location A, and location B into factor rating gives you product of rating of location B. Now you sum up the product and you get the scores. Whichever score is higher, that location you choose. Now in the class also I had told you, now also I am telling you that if the scores are very close, it means that there is need for another in-depth study. Another in-depth study is necessary if the scores are very close. Very close score means it might have been because of taking one location more important than the other or vice versa. Some manual error might have taken place because of that one small score difference. So if the score difference is quite large, then only we can safely say that one location is better than the other location. Okay. The next type of analysis is qualitative factor rating method. Factor analysis method. It is also called weighted factor analysis method. In this, we assign weights to each factor. Again, we list down the factors and assign weights to each factor. And the total weight has to be 1. And for each location, the location score is given. Now, we have to multiply the weights with the corresponding location values. Okay, and once we have done that, we sum over all the locations values, and whichever location is highest, we choose that location. I hope you are referring to the slides because it is impossible to explain without the slides. I'll just show you the slides here. This side you will see the factors. These are the factors. These are the weights, and these are the values. So you multiply the weights with the values. Okay. Next is location break-even analysis, a very simple method. Determination of the fixed and the variable cost for all locations. You find the break-even point for multiple locations, and whichever break-even point is high earlier, you go for that location. Plotting all costs on vertical axis and volume on the horizontal axis of the graph. The location having least cost is selected. That is the least cost at which the break-even is reached. That is selected. The cost has got this kind of a curve, and revenue has got this kind of a curve. And wherever the break-even point meets, whichever cost is the lowest, you select that cost. Next is simple median model. The best location is shortlisted based on lowest transportation cost. In simple median model, we take the transportation cost as the benchmark. Since the model is quite simple and easy to operate. Median means a statistical median of loads to be transported between new and existing channel. So whatever is the existing channel, whatever is the new channel, what you are transporting between the two channels, you take the median of the loads. If there are several loads, you take the median, not the mean, mind you. It is the median you have to take. This model is based upon the assumption that the movement of goods can take place either on x-axis or y-axis, and diagonal movement is prohibited. Why? Because each axis represents one particular location. Okay. Transportation method, you've already known. You already know about transportation method in linear programming. In linear programming's form of transportation method you have done in your previous semester. That is the same as transportation method here. Varying demands are considered and is correlated with the capacity to reduce the transportation cost, optimizing transportation from various factories to various markets. No value addition is made to any of the product under this method. Load distance method is a mathematical model. The next method is a mathematical model used to evaluate locations based on proximity factors. Proximity means closeness. The objective is to select a location that minimizes the total weighted loads moving into and out of the facility. Total weighted loads moving into and out of the facility that you have. The distance between 2 points is expressed as by assigning the points to grid coordinates on a map. The alternative approach is to use time rather than distance. So you can use time also in place of distance between two endpoints. I've given an example here. This example you might have referred to. In this example, this is the current layout, this is the proposed layout, and these are the loads between the layouts. So in the proposed layout, you find out the imbalance. So the proposed layout must either minimize the load than the previous layout, or it should keep the load same. Yes, hello to the students. Next is centroid method or center of gravity method. Here we consider the load and the coordinates. Coordinates are on a grid, on a coordinate you plot where are the points of the locations, which are the locations and where are the points of the location on the coordinate plane and the distance between each location. In centroid method, from the centroid, whichever location is shortest is taken into account, and that is considered as load into the xy coordinate. The x coordinate is found out by summation load I into xi by summation of load I, that is the mean, and for y coordinate it is summation li yi by summation load I, that is the mean of y. So mean of x and mean of y gives you the location, centroid of the location, and from the centroid whichever uh, location, whichever site is nearest is chosen as a location. Minimax location model, it minimizes the distance between the facility and for future existing location. It takes into consideration the worst cases, assuming the distance to be the largest. So in Minimax model, it is assumed that the worst will happen, and out of the worst, what is the possible maximum? Minimums of the maximums. What is the possible maximum advantage we can take out of the worst possible cases? For example, locating an ambulance, the fire extinguisher, etc., is in case of an accident. Next, we have the economic survey of site selection. Remember, students, every single slide is important. Don't miss out on any slide. Every single slide is important. The techniques are over. Now we're going into economic survey of site selection. First is the capital cost. There's the cost of land, land development, building and services like air conditioning, efficient disposal. Then the operating cost, cost of capital, overhead, depreciation, cost of materials and labor, distribution cost, transportation and sales cost, tax expenses, telephone and postage, etc. The most advantageous location is based on the rate of return. What is the rate of return? Total sales minus total expenses by investment into 100. Total sales minus total expenses by total investment into 100. Total sales minus total expenses means the revenue, the total revenue. Sorry, the total profit that you get. Total expenses, total sales minus total expenses. You get the total profit. Total profit by total investment into 100 expressed as a percentage gives you the most, gives you the rate of return. So based on this rate of return, you can survey the site which you have selected. Finally, as per the studies across the world, it has been found out that these factors are most important factors like personal business contacts, transport and communication, availability of infrastructure, size of local markets, availability of skilled labor, and regions promotions effort. These are the most important factors which have been studied throughout the world, and it has been found to be the most important. So if any question comes, if it is the most important factors, these are the most important factors for location selection. So this ends our location study. In the next class, we'll move on to layout study. Okay, thank you very much.